there, mathematicians. Let's do our last homework of the unit. Remember that our test is coming up, so you need to be reviewing. But this is our last official assignment. Okay, we're starting with an easier version where they're already fractions. We're going to divide them. Notice that drawing a model is only if you need it. So here we have 8/4, no, not 8/4, 8/9 divided by 4/9. When we have two fractions, we keep our first fraction the same. We change it to multiplying problem, and we can multiply by the reciprocal, which is 9/4. 8 times 9 is 72. 9 times 4 is 36. Ooh. I can notice though maybe that I see a 9 here and a 9 here. So what if I just went back and simplified them by 9s? That would get me back to the 8 and the 4 that our problem started with. And I can do 8 divided by 4. 8 divided by 4 is 2. No over 1, no fraction. The most simple way to write that is 2. Alright, next one. Also just fractions. 9/10 divided by 4/10. The first fraction stays exactly as it is. We multiply by the reciprocal. And maybe you'll notice again that we're about to have a 10 and a 10. So 90/40 can be divided back down by 10/10 to give us 9/4. That cannot be simplified any further because 9 and 4 only share a common factor of 1, and dividing by 1 isn't going to help us change anything. You could change it to a mixed number if you wanted to, but you don't have to, and I wouldn't. I'd just go, yeah, there's my answer. Okay, I'll set you up for the next one, but I'm not gonna do them with you because we know the steps. So next one, that's not a fraction, that's mixed number. We need to change 1 3/5 into just a plain old fraction. Couple ways you can do it. You can say, okay, 1 whole in fifths is 5/5 plus another 3/5. Ooh, here we go. 1, 2, 3 of them. That's 3 more fifths, and 3/5 and 5/5 makes 8/5. You can try it, you can reason that out, or the process we've been doing is if you multiply 5 times 1, you get 5, because 5/5 makes 1 whole, and then you add on 3 more because we're adding on these extra 3/5, and they're all still fifth sizes, so you keep the fifths as a denominator, and we have a numerator of 8 divided by 1/3. You're going to keep the first fraction the same. You're going to change it to a multiplying problem. You're going to multiply by the reciprocal and simplify as needed. Same deal with D. Keep the first one the same, change it to multiplying, multiply by the reciprocal, simplify as needed. On the back, Alistair has 5 half-pound chocolate bars. That's what's going to trip a lot of people up who don't watch the YouTube video, because it is not 5 1/2. It is 5 half-sized pieces. That's what he has, so that's going first. It takes 1.5 pounds of chocolate to make a batch of cookies. So we want to know how many batches. We're going to divide it up, change this to a fraction, keep the first fraction the same, multiply by the reciprocal. Next up, Melody has 24.5 pages left. If that's what we have, that's what's going first. She needs to write and edit about 1.5 pages a day, or she does write and edit about 1.5 pages a day. So we're breaking it up into groups of 1.5. Both of these numbers need to change to fractions. I'll do the first one with you, you do the second one by yourselves. 2 24s, 24 cut into 2 parts. That makes a total of 48 parts. Plus 1 more is 49 half-sized parts. You change this one into a fraction, keep the 49 halves the same because it's the first fraction, multiply by the reciprocal, and simplify as needed because that actually might be a gross multiplication problem. Actually, let's do that together. Multiply by the reciprocal. This is 3 halves, 2 thirds. I might go ahead and say, hey, I see that I'm gonna have to divide by 2/2. 49 doubled, that's not terrible. But you can see that none of the answers are mixed or improper fractions. So you're going to have to change your answer to a mixed number. Last one. This one is ridiculous because I knit. That's like when you have the 2 needles and you like make stuff. I just think it's really silly because it takes me like a month to make a sweater. And this says that it takes him an hour and a third, like, no, that is not accurate. But those are the numbers in the problem, so we'll still do the problem even though that's very inaccurate because it takes way longer to knit a sweater. But David has finished knitting 12.5 sweaters. That's what he actually has. He can hold them up. He's got 12 that are done and 1 that's halfway done. That's what he has, that's what's going first. It takes him, ridiculous, not true, 1 1/3 of an hour to knit 1 sweater. So you're gonna do this division problem. Again, change these mixed numbers. You cannot just drop them and just write 1/2 and 1/3. You have to change them. How many halves are in 12 plus this extra 1/2? How many thirds are in 1 plus this extra 1/3? You have to change them to fractions before you can keep the first one the same and multiply by the reciprocal. I'm seeing some mixed numbers here too, so you're gonna have to change your final fraction, which will be an improper fraction because we're looking at numbers that are greater than 1 whole. You're gonna have to change that to either a whole number or a mixed number. Can't stay as an improper fraction. It's the last homework. Make it count.